Next we have our question number 28. Let's convert this LHS values in terms of cos and sine. This cot A can be written as cos A by sine A, minus 1 remains same, and here we'll be having 2 minus 1 by cos square A. Now we have to take the LCM of both the terms. We'll get it as cos A minus sin A by sin A remains same, and the whole divided by 2 cos square A minus 1 by cos square A. Let's transpose this denominator or the second factor to the first factor. We'll get it as cos A minus sin A by sin A remains same into cos square A. I'll write this 2 cos square as cos square A plus cos square A minus 1. So first let me keep some arrows. This is the third step completed, and we know that, let's write, we have an identity, right? Sin square A plus cos square A is equals to 1, and we know that sin square A is nothing but 1 minus cos square A. Here we'll be having cos A minus sin A by sin A remains same into cos square A by cos square A minus of, I am taking out minus sign as a common from this 2, we'll get it as 1 minus cos square A. Now in this place we can write it as cos sin square A, right? So here we'll be having cos A minus sin A, and the denominator is sin A, it remains same, into cos square A by, here we'll get it as cos square A minus sin square A, and here the denominator is in the form of A square minus B square. Again we'll expand that in the form of A plus B into A minus B. This first term remains same as it is. Expand the denominator of this second factor. Here we'll get it as cos A minus sin A into cos A plus sin A. So here we can cancel out these two terms. Let's write the remainder values, which are cos square A by sin A into cos A plus sin A. Let's leave it like this. Now we'll go with our RHS. What is our RHS given? Cot A by 1 plus tan. Right. Now let's convert this in the form of cos and sin. This cot can be written as cos A by sin A, and this tan can be written as sin A by cos A. Here we need to take the LCM of this denominator. We'll get it as cos A by sin A whole divided by cos A plus sin A, and the denominator will be cos A. Let's transpose this second factor to the first factor. We'll get it as cos A by sin A into cos A by cos A plus sin A. Let's multiply this. Cos into cos is cos square A by sin A of cos A plus sin A. If we observe here, the simplified LHS and simplified RHS values are same. Therefore, LHS is equals to RHS. We have our question number 29, which is 1 by secant plus cos. This also we have to prove LHS and RHS separately. First we will be proving our LHS value. Here we have R1, which can be written as secant square A minus tan square A from our identities, and the denominator remains same, which is secant A plus tan. And here we have inverse of cos. Inverse of cos can be written as secant minus secant A. Let's expand this numerator in the form of A square minus B square. We'll get it as A plus B into A minus B, and secant A minus tan A, and the denominator remains same, which is secant A plus tan A, and we have our second term, which is secant A. that both term of numerator and denominator gets cancelled. Our remaining values are secant A minus tan A minus secant A. This plus and minus values gets cancelled. Our remaining value is minus tan A. This is our LHS simplified value. Let's go with our RHS, which is 1 by cos minus 1 by secant A minus tan. Again, this inverse of cos is nothing but secant. Again, we'll write this one in the form of secant square A minus tan square A. And the denominator remains same, which is secant A minus tan A. Again, we'll expand this numerator in the form of A plus B into A minus B. We'll get it as secant A minus secant A plus tan A into secant A minus tan A whole divided by secant A minus tan A. So here both the terms gets cancelled. Our remaining values are secant A minus secant A plus tan A. Let's multiply this negative term to the terms which are inside the bracket. We'll get secant A minus secant A. Plus of minus is again minus tan A. This plus and minus gets cancelled. The remaining value is tan A. This is a simplified RHS value. So if we see our simplified LHS and RHS values are same, therefore LHS is equals to RHS. So question number 30, this also we have to prove LHS and RHS separately, and we have to convert all the values in terms of sine and cos to make our answer easier. Leave this sine A as it is. This cot can be written as cos A by sine A, and cosecant can be written as inverse of sine. This is the first term, and here we'll be having sine A. Here we are having same denominator, so we can directly combine the numerators of this denominator, and we'll transpose this to the numerator. We'll get it as sine square A by cos A plus 1. And from our identities, the sine square can be written as 1 minus cos square A. And this denominator is same. It is in the form of A square minus B square, which can be written as A plus B into A minus B. A plus B into A minus B. And the denominator is cos A plus 1. Here cos A plus 1 gets cancelled. So our remaining value is 1 minus cos A. As of now, this is our simplified LHS value. Let's go with our RHS. Here also, convert this in the terms of cos and sine. Here we have 2 plus sine A by cot can be written as cos A by sine A, and this cosecant can be written as inverse of sine A. Again, here we have same denominators. So again we'll be doing the same thing. We'll get it as cos A minus 1 by sine A. Again, transpose this to the numerator. We'll get it as 2 plus sine square A by cos A minus 1. Again, write the sine square in the form of 1 minus cos square A. And here we'll be having cos A minus 1. This will write it as 2 minus of cos square A minus 1 by cos A minus 1. To get a same term, we are taking out minus sign as a common term here. Now again this we can write it in the form of A plus B into A minus B again by cos A minus 1. Here cos A minus 1 gets cancelled. Here we'll be having 2 minus cos A minus 1, which is nothing but 1 minus cos A. This is our simplified RHS value. So here we got same simplified values. Therefore, LHS is equals to RHS. Next we have our question number 31. We'll convert this in terms of sine and cos, because we need to get our RHS in terms of sine and cos. We know this cot can be written as cos by sine, and tan can be written as sine by cos. Here we'll be taking the LCM, that is nothing but cross multiplication we have to do. Cos square A minus sine square A by sin A into cos A. If we observe here, we need to get our answer in terms of cos square in numerator. From our identities, we can write our sine square A as 1 minus cos square A. Let's replace our sine square with 1 minus cos square. We'll get it as cos square minus of 1 minus cos square A, and the denominator remains same, which is sin A into cos A. Now let's multiply this negative term to the terms which are inside the bracket. We'll get it as cos square minus 1 plus 1 cos square A by sin A into cos A. Cos square plus cos square is 2 cos square A minus 1 by sin A into cos A. This is our required RHS value. Next, our question number 32. Here it is in square root. We'll try to remove that square root here. Let's multiply this LHS side with 1 plus cos A and 1 plus cos A to the numerator, and denominator will get it as 1 plus cos A by 1 plus cos A. And here 1 plus cos A into 1 plus cos A is 1 plus cos A whole square, and here we can write it as 1 minus cos square A. And 1 minus cos square, we know that it is sine square. 1 plus cos square by sine square. So here I'll write the square as a common. We'll get 1 plus cos A by sin A whole square. This square and root gets cancelled. And here I'll write this numerator as two different terms. We'll get 1 by sin A plus cos A by sin A. And we know inverse of sine is nothing but cosecant A, and cos A by sin A is nothing but cot A.